Hey everyone, FusedVR coming at ya, and today we've got another sponsored video by Intel covering this pretty awesome device, the Intel NUC 8th Gen. But before we dive into that, I wanted to talk a little bit about the sponsorship, and this is a sponsorship by Intel to promote the Ultimate Coder Challenge. Now, what that is a contest where they've picked out 8 teams already that are going to be competing across a variety of different applications that they're building in VR. So these videos here are to talk about some of the stuff they're using, follow along with them, as well as just kind of talk about the contest in general. I saw on the last video there are a couple comments there about being able to participate. Unfortunately, that is not the case. That might happen in the future. But needless to say, I think fundamentally Intel's goal in this is to promote VR development and make it something that is exciting and applies to a lot of things outside of gaming. So that is one of the reasons why I chose to accept this sponsorship, and one of the reasons that we're covering it on the channel today. And with all of that said, I hope you guys enjoy. This is the Intel NUC 8th Gen. It is basically a desktop that is capable of running virtual reality at a much better scale than even the minimum specs for VR development. And I think that's really, really awesome that they're able to put that in the form factor of what is effectively just a router. And that's really, really incredible. So real quick, before we actually go into some more details on this, I want you to go ahead and comment below what desktop you're running for, or laptop, or really whatever device you're running to do your VR development, because I'm really, really curious to know what that is for all of you guys. So with that said, what is this thing? So it is a portable, easy to demo machine that you could take to a conference, so like just put around the office. Doesn't really matter. Hold it in your hand, toss it around if you want. Don't worry, I'm being super careful right now. Or even if you really wanted to, maybe try to put it in backpack VR. There are some limitations just because of due to thermal heating, but that might be a possibility, especially if you get the right ventilation for this. And I think that's super, super awesome. Now, this device is being used in the Ultimate Coder Contest as kind of the baseline device to use for development and testing across everything. So there shouldn't really be anything as far as like performance difficulties, because that's literally the same for everybody. And having tried that out myself, I'm actually pretty impressed. I mean, you'll see on the screen right now, we've got running a few different types of VR applications, from Beat Saber to Tilt Brush to budget cuts, really anything you can think of, trying to test the limits of this thing. And it works really, really, really well. And I mean, it's a Intel CPU i7 paired with an AMD Radeon RX Vega. And it's an extremely small chip, and it just fits perfectly into here and allows you to get that high-end graphics as well as the high-end compute power that you actually need really for any VR application of any kind. Surprisingly enough, when you develop in Unity, you're actually going to have a fair amount of your code that runs on the CPU versus, say, your graphics that's running on the GPU. And that's important to have really good hardware on both sides to really maximize the performance of really anything that you run. As far as ports go, it has 2 HDMIs as well as 2 mini display ports. So in total, if you really wanted to stretch the limits, you could, in theory, actually go ahead and output 4K through all 4 of those outputs. On top of that, you're going to have 6 USBs, 2 in the front, 4 in the back, which I think is just super, super useful, especially for VR. Just having quick USBs that you can plug into the front, or just a mouse or a keyboard, really doesn't matter. You can plug all those in and be perfectly fine. It actually works perfectly with the fact that you need a lot of USBs for Oculus, so you'll have a surplus there if you really, really need to. Price-wise, we're looking at $800 to $900. Hopefully that goes down during time, because it's about the same price as when desktops first got introduced into the marketplace for actually using on the Oculus and Vive. But I think in time, that price will go down. And you got to remember that the form factor here is really what's driving up the price. Just the pure fact that you actually have something so small and so condensed is pretty remarkable engineering-wise. So it's going to start fairly expensive. I mean, just kind of baseline with other desktops and hopefully move down in price. So you're looking at, if you got the Windows VR headsets, to actually be doing $300 plus $900, so about $1,200 for this whole system to actually be putting out VR. Of course, for most of you in the audience, you might already have VR. So if you don't maybe have a good desktop or kind of want to upgrade, this is probably not a bad choice. It's on the higher end price-wise, but I mean, just the fact that you can bring this around literally anywhere for development is pretty awesome. All right, so we're here into this very basic Unity project. You can see here, this is what I'm calling the ball pit. It's basically just 1, 2, 3, 4, 5 Unity planes, just that form a ball, and inside it's sealed. So from when you look at it from the outside, since it's only rendering the inside, you can basically see through. So that's just kind of the setup. And we have a prefab here, which is our ball, and we're going to be basically spawning this all over and over again. It is just like a Unity sphere, and it has a collider and it has a rigid body so that we can simulate physics on it. So basically the way this is going to work is we have our spawner up here. It's going to drop balls here until it fills it up, and of course afterwards everything's going to fall over. And what we're going to be doing with that is measuring the vert and try counts, as well as the set pass calls and our FPS. We'll also have a shadow caster in there as well, although that kind of gets slowly optimized over time. But the main three things are kind of the vert count, the number of set pass calls, and the FPS as we spawn more and more balls. Now, in case, just to explain everything, vert count is how many vertices and how many polygons we're putting into the scene, which basically means the higher you're doing it, the more complex the renderer has to work in order to render out everything. Set pass calls is for your materials. Now, there are certain optimizations, especially with prefabs, that if you're using the same material over and over again, it can optimize everything out tremendously, and the set pass calls is basically very small. So to avoid that with the spawner, we're actually changing the color and dynamically setting a material for each and every ball. So there are going to be so many materials that are going out there, and the set pass calls just rise and rise just in each and every time, because each one is dynamically different from everything else on the prefab. So that's really how this works. Very simple. We have just one light in here just so that we can actually see everything that's going on, since we're using lighted stuff and we can get shadows. And let's just quickly dive into the spawner code. Now for the spawner, we need our sphere prefab, and we just need to set a spawn interval, which I'm doing here within Unity. Now, every update frame, we're basically going to be checking to see if the time has passed that's greater than the spawner interval, which we'd set to just 1/4 of a second. So we're getting 4 balls that spawn every second, and then we instantiate that. And to avoid everything just kind of stacking up, and we kind of want it to fill the ball pit, I'm going to adjust the actual place where it spawns by just from 0 to 1. So it's just kind of just a little bit off, which is enough to get the balls kind of actually simulating physics, which is what we actually want to do, to just kind of push the CPU a little bit. And then on top of that, we are just kind of going ahead, reset the cure time. And then the last thing is, like I said, set the material, just the color, just to a random color. It really didn't matter that you could set this however you want, but we're just kind of setting it to a random color so that we can set the set passes. And that's really it, just code-wise, because all we just really need to do is create a simple spawner that just spawns a bunch of balls. All right, so here we have a simulation going with the ball pit demo, and this is running on the Intel NUC, which we're going to use as kind of our performance test, and we're going to compare this against my kind of default dev machine, which is my Asus. And we have just the stats here going on. You can see the verts and the set pass calls going up and up and up as we simulate this, and the frames per second slowly starting to go down over time. we're actually seeing that we're able to actually hold about 3 million verts and 3,000 set pass calls before the frame rates start dipping below 190 frames per second. So that's kind of the baseline here that we're going to be using to compare against the other machine. And we're also going to go ahead and just kind of check this out as we like move the headset, just so that you guys know that this is running on a Vive and it is in VR. So that's one of the reasons why we're getting a high frame rate anyway. So go ahead, pick this up, and obviously, like, the more we look at these balls, the set pass calls go up and the verts go up. But the nice thing is that Unity will also optimize so that when we don't look at anything, it's going to have a very nice frame rate. So basically, just keep in mind here that on this dev machine, you're going to try and hit 3 million verts and 3,000 set pass calls, which honestly is a lot higher than what Oculus even puts in their documentation as well. So keep that in mind, that it is fairly performant even within Unity here. Now, I'm going to go ahead, simulate the same thing here on my Asus, which is running an i7 and a 970M GPU. So you should know right off the bat, it is fairly weaker here. But even that said, it'll still be able to pump out a decent amount before the frame rate drops. So we're getting here around the 2 million verts and 2,000 set passes. It's kind of funny how they go hand in hand here, but we're at that point realizing that the frames per second start dipping below the 90 frames per second, which is what we want to keep for the Vive. And I think there's an important note here, is that this is probably the normal min spec, about 2 million verts and about 2,000 set pass calls for high-end VR. You can go higher than that, but keep in mind it might not work on those min spec devices that you might also want to support. So it's a very simple test, but a test nonetheless to also make sure that you're running very performantly across multiple devices, which is always key for VR, especially desktop VR, because you never know what people are actually going to be running on. So I've gone ahead, slowed this down here. We'll pick up you can see it is a lot more chop here than when I was running on the Hades. But I mean, it's obviously, we've gone about 1 million plus 1,000 set pass calls higher than it can actually handle. So it's going to be a lot choppier, but of course, this is just a test, and as a test, we're supposed to expect all of this stuff. So in conclusion, it's a extremely awesome way to demo this in any kind, run mixed reality, just put it out in arcade, doesn't really matter, and just take up a lot less space than your normal just Titan desktop tower. And it's, I think, a great way to be a benchmark for all the contestants. I mean, think about, just imagine if you didn't have a device like this. You're now having to run and test across a variety of different desktops, which might not put out the same performance, even if they have the same CPU and GPU, which is pretty unlikely for the most part. So I think it's a great way for the contestants to actually go ahead and just have an equal and level playing field. So that's super awesome as well. One caveat that I should mention is that while this is a great demo machine, and while it may be extremely portable, I don't think it's a great dev machine for two reasons. One, the fact that Unity in and of itself doesn't really play well with AMD. That's just kind of been my personal experience, which I think is unfortunate. They output to AMD hardware really well. So like if you're running VR, like as an actual Unity application, it'll work great. But just dev-wise, I've found it to like stutter frames from time to time, or just like slow down randomly, which I haven't really come across when I go on NVIDIA hardware. So that's just something to note, just dev-wise. If you have a separate dev machine, that might be better, and then just using this for demoing. The other thing is, because this is actually better than the minimum spec, you might want to actually test your applications on a lower-end desktop or a lower-end laptop. The reason being is, if you use this as the min spec, you're going to leave out a lot of people that might be using 950s or 960s, like Oculus actually lets as the min spec, or 970s, and you don't really want to have that happen. I strongly recommend, like, if you're actually trying to push to the mass audience or just consumers in general, you want to run on kind of the bare minimum hardware. So that's also something to keep in mind, just so you you don't develop on this thing, and then you're like, wait, why am I getting so many complaints as to why this I don't have a performant application that runs well on my devices? Just because not everyone has this device. So keep that in mind as well. So I just wanted to throw those two caveats in just because you never know what you might come across as you're developing. So just keep that in mind. But I mean, otherwise, I think this is a fantastic device. And if you are going to conferences or just having an arcade, I think it's super, super valuable to have something that's like low cost, or not low cost, but takes up a lot less space and can just go from place to place really fast or from hand to hand really fast. So that's it for this video. Hope you found this super helpful. I think it's really incredible to have something on the market and just talk a little bit about this. And really thanks to Intel for giving this to me so that I can actually run some tests and test it out and share that knowledge with you guys. So thanks so much for watching. Until next time, this has been FusedVR, and I'm signing out.